Today we are going to start with signal flow graph. Till now we were discussing about block diagram reduction method to find the transfer function, but we have seen that that was very complex technique. Block diagram reduction method was very complex method. Why? Because if we have some 5-6 block also, there also we find difficulty to solve for transfer function, right? So there is another technique, signal flow graph. This technique is also used to find transfer function only, right? If there is a question for what purpose signal flow graph is used, we can say it is used for transfer function, right? Signal flow graph was given by S.J. Mason. By using Mason gain formula only, we can find transfer function of the system. And now first of all, signal flow graph, what it is? It is a graphical representation that deals with relation between variables of the system that are described in the form of set of linear algebraic equation. That is the basic definition of signal flow graph. Signal flow graph is graphical representation that deals with relation between variable of the system that are described in the form of set of linear algebraic equation. This is very important. Equation must be linear. See how signal flow graph was developed. Signal flow graph was developed from cause and effect theory. According to this, effect is equal to gain. There may be multiple gain associated with the particular cause and multiplied by cause. According to this theory, this signal flow graph was developed. Now we have an equation y21 equal to a and y11. So how do we represent? We represent y21 as one element and y11 as element, and direction is going to this, right? So and this is how signal flow graph of this particular linear algebraic equation. Now what happened, actually this is terminology we use from left to right. Generally cause and effect theory says input at leftmost and output is rightmost, right? So that's how we represent, but it doesn't mean that we cannot represent like this. We are very much permitted to represent it like this. That doesn't make any difference. But one more thing, signal can be transmitted along this direction only, direction shown. It cannot be in the reverse direction. And from equation, see, we can write y1 equal to 1 upon a y21, right? This equation may be mathematically correct. But we cannot represent its signal flow graph like this. y11 y21 multiplied by 1 by a. This is wrong. Because signal can transmit from input to output only. Here y21 is output and y11 is equal to input. We are assuming for this case there may be another parameter associated, but since we are taking very general case at beginning, so we are taking like this as input and this as output. So this is wrong. This may be mathematically correct, but we cannot represent signal flow graph in terms of the signal can be transmitted from cause to effect, cause and effect, and this is associated gain. So effect cannot produce a cause. That is the theory behind development of signal flow graph, right? So, and one more thing, you have seen this simple equation only, but generally signal flow graph consists of number of mathematical equation. So signal flow graph involves mathematical equations, right? But when we were discussing block diagram reduction method was very liberal. That may be complex, but that was very liberal. Only we were associating some gain, and we are just manipulating our circuit and we were getting, but that is not the case with signal flow graph, right? Now let's look at some of the properties of signal flow graph. Properties of signal flow graph. First, it is applicable to linear system. What it is? Applicable to linear system, because we have seen that we require only linear equation, so that is why it is applicable to linear system only. If system is not linear, then it is not possible to describe that system in terms of linear equation. If we cannot describe that system into linear equation, then it is not possible to obtain signal flow graph of that system. Second, and it is a property, second property is it is made by cause and effect theory. Cause and effect theory, that means you cannot interchange cause and effect by reversing the direction, right? Third thing, nodes represent variable. This is one variable, this is another variable, so nodes represent variable. Fourth property, signal travels along direction only, right? We have discussed this thing, that signal can be transmit from this direction to this direction. Reverse may not be true, because effect cannot cause its cause. So that is the reason signal travel along direction only, right? And say if we have path yk to yj, then yj by yk exists but not reverse. Again the same meaning, that signal can travel along direction only, right? And next we see relations between signal flow graph, relations between signal flow graph and block diagram, right? Let's see very general case. If we have a GS gain and I have a output and I have a input, then how can I represent it like this? Here these are two variable and gain is associated with this, right? Y1 here and Y2 here, there are two variable. right? We will see how we can make output node and input node from this thing, but for the sake of understanding, gain is represented. I want to emphasize the thing that this gain block is represented by this arrow and value mentioned above this, right? Now see, like we have this GS and I have a negative feedback HS, and I have a YS, here I have a US, right? So how we represent this is this block as GS, right? And this is as minus HS. Minus HS is because of this negative feedback. We don't have any mechanism to represent negative here, so I will represent minus with HS, right? And here say it is US, then it is say some other signal, say ES it is, and then this signal is ES, nothing but ES. And with unity gain I can represent US like this, and with unity gain CS YS we have taken, so I can represent like this. So these are output node and this is input, right? We will see how to determine that thing now. And let's take some set of equation and let's see how to draw its signal flow graph. Like question a system is described as like xt x1t plus beta 3 ut and x1 dot t is equal to minus a1 x1t plus x2t plus beta 2 ut and x2 dot t is equal to minus a2 x1t plus beta 1 ut, and it is asked that find access by US using signal flow graph. Now if we see this, I can represent US as input and access as output, right? So let's look. First of all, solution. First of all, what we take Laplace of equations. First we will take Laplace of all these three equations. So let's see how we can represent XS is equal to x1s plus beta 3 US, right? And this is first equation. Taking Laplace of second equation is s x1s is equal to minus a1 x1s plus x2s plus beta 2 US, and so I can simplify this as x1s is equal to minus a1s x1s plus 1 by x2s divided by s and beta 2 by s US. Why I am not taking x1s to this side? Actually x1s this here it represent self loop. We will see how we will represent this as self loop. If we take x1 as this side, then we will remove self loop from the signal flow graph. That is not necessary. We can even remove. Signal flow graph is actually not unique. Only thing is gain will change in that case. So here I want to show self loop. That's why I am not taking x1s to this side, right? And third one, taking equation third Laplace is s x2s minus a2 x1s plus beta 1 US, right? x2s will be equal to minus a2 by s x1s beta 1 by s into us. Like this is our third equation. Now what, see, we have seen us as input, so I represent this node here us 1 with unity gain 1. So this is our input node, this is our input node which is taking input, only one branches with input is coming, right? And here we have two variable x1s and x2s, so I can represent x2s here. It is not unique, we can rather represent x2s here or x1s here, that is your wish. Only thing is little bit graph will be changing. For the very simple graph I am taking this, and you can take other way also. This is x1s and here let's say xs. Now represent x2 will be equal to, here us is coming, multiply by beta 1 by s, beta 1 by s into us, here it is coming, and x1s from here it is like minus a2 by s. So this complete my x2s. This is adder, this is working as adder now, right? So x2s will be equal to beta 1s beta 1 by s into us, right? This thing minus a2 by s into x1s, right? Now represent x1s. Now x1s, x2s is coming, x2s is coming to x1s with gain 1 by s, right? And x1s is taking beta 2 by s into us, so I will take us from this point and it will go to x1s with gain beta 1 by s, right? And also x1s as x1s multiplied by minus 1 by s minus a1 by s, right? I have said this thing that if we take this side, then this self loop will be removed. I wanted to show this self loop here, that's why I didn't taken that side, but you are very much permitted to take that side also. Only thing is this gain values will be changing, and xs will be equal to x1s, take it with unity gain, and beta 3 us, take us from here and reaching here, so beta 3, right? So this is our complete signal flow graph. Now it was asked to find access by us using signal flow graph. That thing is very straightforward. Till now we haven't covered the formula by which we find this access by us, the transfer function, so leave it for now. When we are done with our formula, then we will see how to find transfer function. Right now I wanted to show this signal flow graph only, right? Now let's move to another thing. We have discussed the relationship between block diagram reduction and a signal flow graph. Now let's look at example. We have given a block diagram, this one, this go this way, g1, and this thing g2, and here it is coming output, right? And here it is input, and here we have a feedback h coming from output, and it is negative feedback. Here one element is here, g3, going from input to adder, this is positive. Now I want to represent this block diagram into signal flow graph. How do I represent? First of all, we need to represent this block diagram, we need to know how many nodes we require in signal flow graph. So number of nodes required in signal flow graph will be equal to total number of adder and takeoff point. First of all, we need to know total number of adder and takeoff point plus one input node with unity gain to represent our input, plus one output node with unity gain. Right, so let's look at number of nodes required in this signal flow graph. One adder and second adder, and here it is, this also takeoff point, third one, and here it is fourth. Right, so we have four number of adder and takeoff point plus one input node for this thing and plus output node for this thing. Total number of 6 node I require. So let me mark 1 2 3 4 5 and 6, and 2 node will be with unity gain, so I represent it like 1 with US and 1 here with US or RS, and here YS. Right, so let's look this point from this to this takeoff point to this is point 3 and this is point 1. Right, so here we have unity gain between this takeoff point and this adder, so I represent this as unity gain. Now between first adder and second adder we have again G1, so I represent this as G1. Let me remove this point, else we will get confused. Right, G1, and then from this adder to this takeoff point we have gain G2. Right, and from this last node to this adder we have a gain of -H because of this negative feedback. Right, from this point to this point we have a gain of -H. Right, and from this first takeoff point to this last adder we have a gain of G3, so from this point to this point we have a gain of G3. Right, this constitute our signal flow graph, equivalent signal flow graph from this block diagram. So whenever we are asked to find transfer function, we can even use block diagram reduction technique, or we can use signal flow graph. How we can use signal flow graph, that we will see very soon. Right, and this thing is very important. Number of nodes required in signal flow graph, total number of adder and takeoff point plus one input node with unity gain plus one output node with unity gain. Right, and now let's see one more example. We will be dealing with sometime electrical network. So let's look at how do we represent electrical network in form of signal flow graph. First of all, see, this is our R1 and this is given capacitor 1 by SC, and R2, and this is L inductor SL. Now we have an input supply here, input supply, and we have here we are taking output. We have voltage associated with capacitor as VC, and we have current here following. Let's represent it by I2, and here current will flow. Let's represent this thing by I1. Now we have first of all we need to represent these things. This is a linear network. First of all, it is very important to understand that since this is a linear network, so we can represent this in its equivalent, either block diagram or in signal flow graph, but we are going to represent this in terms of signal flow graph. So what we need linear equations. We already know that I expect you have some knowledge from your network theory. These resistance, inductor and capacitor are linear elements, right? So if these are linear element forming a linear network, so it is very much possible to obtain linear equations. Linear equation we will get in terms of V0, I2, I1 and Vi. V0 will give a relationship for output, and these are the I2, I1 current flowing through this, which will from which we can obtain even VC, right? So first of all, let's write I1. I1 will be equal to Vi minus VC, Vi minus VC divided by R1, right? And VC I can represent as current flowing this direction, I1 minus I2 by SC, right? This is equation for VC. And third thing, we need to get I2. I2 we can get as VC minus V0 by R2, and V0 is equal to I2 into SL. So we obtain 4 set of equation. So let's look how I can represent this in terms of signal flow graph. First of all, we need to identify how many nodes we have. I1, we have I2 and we have VC, right? So 3 nodes we require, plus 1 input node plus 1 output node. Total 5 nodes we require, right? 1, 2, 3, 4, 5. Now this will be with unity gain, and here it is, this thing, and let's represent this thing as I1, and this as VC, and this as I2, right? Sorry, this is not unity gain. Here we have V0, Vi, VC, I1, I2. So total 5 node plus 2 node for input and output. We require total of 7 node, right? So 5, 6 unity gain, and this is here unity gain, and we have a Vi. First of all, write I1. I1 is equal to Vi by R1, 1 by R1, right? And minus VC by R1, that is taking from this point, minus 1 by R1, right? So this completes my first equation. Second, VC equal to I1 by SC, I1 by SC, I1 multiplied by 1 by SC give rise to VC first term, and here it is coming from I2, this is minus 1 by SC. I2 multiplied with minus 1 by SC get added with VC term, right? Now I2 is equal to VC by R2, so 1 by R2 into VC, and here it is like V0, and V0 is equal to, sorry, multiply with minus 1 by R2 give added in I2, right? And V0 is equal to I2 multiply by SL, so here it is V0. So this complete our discussion from making signal flow graph from our electrical network. Whenever we are dealing with electrical network, so we can take anything as output. I2 can be output, VC can be output, I1 can be output, and V0 we have taken output. In this case, the only thing we need to do is, if I want to make VC as output, I can take it as gain 1 and I can represent this as output. If I want to represent this as output, take gain as 1 and make it as I2 output. So, and if I want to make I1 as output, then take unity gain node branch and represent it as output, right? But this thing we cannot do with input node. This thing can be done only with output node only. Suppose I want to make I1 as input, and I do like this, unity gain, and this is 1 I1. This is wrong. This we cannot do. Strictly speaking, this we cannot do. We can only take this as VI input. This thing we can do, this procedure can be done to find output only, but input will be strictly VI only, right? So this complete our discussion of electrical network convert into signal flow graph. Now we will see how to find a transfer function from